If you've been trying to test your offensive skills in Azure AD, you probably would have heard of something called road tools. Now, in this video, I have Lance Kane from SpectreOps who's talking about how you can use a single page application to get refresh tokens by adding a simple header like origin. Yes, this video was also created as part of the Advent.Cloud Security, so you can also find this on advent.cloudsecuritypodcast.tv. But for now, let's walk through with Lance on how you can use a single page application to add a origin header and get some new refresh tokens. Let's get into the video.
Hi there, and happy holidays. My name is Lance Kane, and I'm a senior cybersecurity consultant with SpectreOps, part of the adversary simulation team. I tend to focus on red teaming and penetration testing, and do a lot of work on macOS and cloud security technologies. This was all based on lessons learned from one of our recent security assessments. And the information coming out of that assessment, I was able to actually integrate some changes into Dirk John's Road Tools security tooling. Really cool tool set for anyone that hasn't really utilized it. I know one of my go-tos whenever I'm looking to enumerate Azure environments. During our last assessment, we found some different ways we could extend that tool set to be able to leverage and essentially gain access to enumerate our client environment using single page applications, refresh tokens, and in theory, you could also use just the standard access tokens to be able to enumerate any Azure environment for even common Microsoft applications that we'll be taking a look at today for things like the portal or Microsoft Office web apps. My goal and hope is to be able to share some of this information so technology professionals can better secure their Azure environment and gain some insights into potential avenues they may be exposing to any of their user base that uses single page applications to be able to enumerate and gain more information than may have previously been known. So yeah, a little bit more background on this. During our client cloud security assessment for their Azure tenant, we were tasked with discovering attack paths and misconfigurations, with our overall goal being to escalate privileges and abuse any access that the client provides to their low privilege, non-technical users in their environment, thus emulating any type of compromise or breach in their organization from a low privilege user. When we started the assessment and started trying to get some more insights into their environment, we discovered that their team was doing a lot of things right. They had hardened their environment by modifying the default Azure token lifespan so that it would only be 1 hour instead of 8 or 10. They also shortened refresh tokens so that those would only have a valid lifespan of about 4 hours. They configured their tenant to require administrator approval for any new application enrollments, especially for any coming from outside the organization. So that limited methods of obtaining access, or there was restrictions on the Azure portal itself. The low privilege account was allowed to view Azure resources, but couldn't necessarily enumerate subscriptions, and it was blocked from being able to view the conventional Entra ID pane. Viewing any of the organization information for like their identity was restricted within the web app. Again, they were doing a lot of things right in limiting that access, because why would a low privilege user need to be able to go through and enumerate the organization in that manner, or their applications and other registrations? They also had some really good allow listed conditional access policies, so there wasn't a lot of default access provided and restrictions. Instead, they were kind of doing the inverse of requiring explicit compliance via extensions and network IP ingress to their Azure resources. So that really forced our team to try and like thread the needle or use any of the provided access instead of being able to enumerate things from external infrastructure. This is great, and what we love to see whenever we're working with mature clients that we've had previous assessments with that have hardened their environments over time and began locking things down, making us not only look at the low-hanging fruit and common avenues of exploitation, but also being able to start looking for new avenues and perspectives. And that's kind of what led into this new tradecraft. We were provided a Windows VDI instance or virtual desktop infrastructure instance with a low privilege user account that was granted access to log into the Azure portal. And we were also authorized default Microsoft applications like Microsoft Word, Teams, OneDrive, many of the things you would expect to find in Azure enrollment for default Microsoft licensing. We discovered that in the Azure portal, despite not being able to necessarily enumerate our subscriptions, our team was able to interact with the Azure Cloud Shell, and we just were able to obtain Azure Access tokens by running commandlets like get AZ Access token. We thought this was a quick win or something that we could use to accomplish our objectives of starting to enumerate that Azure tenant and get further insights. And it did start working for us. We ended up running Azure Hound and starting Road Recon collections during the assessment. But unfortunately, we discovered that those tools ended up erroring out after 1 hour, which for anyone that's done Azure enumeration with some of this tooling before will quickly learn that an hour of collection, this is a massive client tenant, which is true. Like we were like, okay, so it's collecting so many resources that where we're going to need to be able to refresh that token or gain a new access token in order for these tools to complete their collections and for us to be able to start reviewing everything that is being gathered throughout this process. With the access tokens failing out, that sparked some more curiosity, and we started looking at the access that was provisioned to us. And I ended up looking at the browser traffic when I was authenticating via the VDI instance in the context of the low privilege user account to the Azure portal, as well as the Office 365 web resources. And while I was observing the traffic, I ended up seeing refresh tokens that were being exchanged when interacting with these web resources. I recalled Andy Robbins mentioning at the SpectreOps Azure Security Fundamentals training that I was attending that the Microsoft portal essentially was a web front end that ended up communicating with Azure's Graph APIs on the back end. So much of the functionality that comes from that is actually just using tokens with browser interactions to submit API requests whenever you're going through and looking at any of the resources, subscriptions, account information, etc. And I also was aware of like the Selenium browser authentication, which is just one method where you can try and authenticate to Azure web apps and use that to obtain access tokens. Unfortunately, that was not an option during this client assessment because of requirements in place for like extension and host checking that would occur whenever you were doing the multi-factor authentication to the client's Azure environment. Again, kudos to them for having set that up and restricting the browsers and setting requirements on like certain extensions to be available whenever we were performing that authentication. Still, having seen refresh tokens in the traffic, I ended up attempting to use those to obtain an access token in Road Recon. And I ended up encountering an error message about single page application cross origin requests. Azure was essentially expecting a refresh token it issued to one of these browser-based web applications to include some information pertaining to like the client ID of the web application, as well as what I later discovered would be the origin header to be included in any authorization requests that wanted to obtain a new access token. After some searching on Stack Overflow and doing API testing based on some additional information, I ended up discovering that if you submitted a Azure token access request with the origin header in your web application request and the appropriate client ID, then you could actually use the refresh tokens that were being returned for single page applications to obtain a new access token. Now we had a method, or at least knew the pieces needed to be able to refresh access tokens. And luckily, Road Tools had already built in the capability to use refresh tokens whenever collections are taking an extended period or an access token would be getting ready to expire. Road Recon will automatically try to refresh that for you. It just didn't necessarily have the logic available to know about sending the origin header and being able to appropriately handle that piece whenever it was submitting a access token request. So with this new knowledge, I ended up updating my local road tools installation to include origin headers in some of those requests when I was supplying the single page application refresh tokens. And as a result, after a little bit of trial and error, we were able to obtain a full collection using Road Recon of our client environment. Our client was very glad to discover this new, previously unknown method of enumerating their Azure environment, and it definitely contributed to one of our goals of like identifying new attack paths, and it allowed us to begin digging further into the service principal permissions and groups and access that was provided for where our seeded user account existed. Definitely a great moment that kind of pushed things further for our assessment. And now I personally, and I know some of my team members commonly employ this tactic whenever we're doing some Azure work, whether it's like pivoting from on-site networks during our red team engagements and penetration tests to Azure Cloud, or if we're tasked with just pretty much Azure focused assessments. Being able to leverage just any web application access, most commonly Portal or Microsoft 365 services, to be able to obtain those tokens, whether covertly or if we're granted access during those assessments, makes things rather efficient, especially when we're trying to maximize the time spent analyzing information instead of trying to find ways to get the information. So I want to go ahead and take a look at what the workflow might look like for someone that's looking to enumerate an Azure tenant using a single page application refresh token based off of the new contributions I was able to make. Here's the pull request with adding the origin argument, and you can see a brief little excerpt about how someone could potentially use the new origin value parameter with something like portal.azure.com to be able to obtain an access token. For anyone that's brand new to this, Road Tools kind of spoke to it a little bit already, but great repo, constantly maintained and being improved by Dirk John and a lot of the other community. You can see more contributors here on the right, and has installation instructions right on its GitHub page. I typically follow right along with creating a virtual environment and then pip installing my tooling. And from that, you're up and going. But let's go ahead and take a trip on over to portal.azure.com. And before I hit enter on that, I'm going to go ahead and open up the inspect window. And we're going to start looking at the network traffic. Particularly, you can see that I've already been checking out token exchanges previously. So that's cached, but you're going to want to filter for token just to make life a little bit easier and make sure you are grabbing specifically only the network requests that pertain to access tokens or refresh tokens we're interested in here. So now we're going to be redirected. We'll authenticate. This is going to be my development / testing account within my Spectre Dev tenant. And authenticating, here's our typical sign-in. Now I've got to grab a code real quick. We're still filtering on tokens there. We'll throw that code in there. And we'll hit yes. Once we are authenticated, we can start seeing our filtering is doing its job. We have a lot of requests going through, but immediately we have access to some of these tokens, and you can see the payload here, one of the previous tabs. Normally it'll pop up with just the headers. We can see this is coming back for login.microsoftonline.com. One of the cool things is you'll be able to hit the response and see the scope for where these tokens apply. And anyone that goes and does further testing will quickly identify not all tokens are created equal. So some of these, whenever we're seeing management.core.windows.net, yes, you can use the refresh token that is provided for that specific scope. However, you need to be aware that whenever you're performing Azure collections, you may encounter some errors or get 403s from Road Recon as it's doing its gather actions. And this typically means there's limitations on certain information that can be accessed with the tokens that are gained from these refresh tokens, whether it's going to be limitations on enumerating devices or certain identifiers. That's not to say this isn't beneficial. Like you can still get a partial collection completed using these refresh tokens, but often there are other scope tokens, or if you end up interacting with some of the additional resources in the portal, you may end up identifying additional tokens that are exchanged for alternate scopes. And here we have like graph.windows.net for restricted user impersonation. And this, you could potentially grab the access token out of the response here and use this alone to try and complete your Road Recon collection. And if the tenant is small enough and the token lives long enough, then you don't even need to worry about using the refresh token. But alternatively, once we see that we have graph windows.net token here with user impersonation, we'll just go ahead and grab that refresh token and we will save it out. One other thing you definitely want to pay attention to is you're going to want the URL for whatever your origin is going to be, where this token or single page application that you're interacting with originally obtained the refresh token. And the last piece is you are going to want to grab a client ID. When we're looking at the payload here, you can often frequently find the client ID for the application. However, in this case, we'll see that we're interacting with portal.azure.com, but we get a different client ID here at the top. And one of the things you can see is that this is actually scoped to whatever unique UID this is. And that is what ended up being replaced in the graph.windows.net token request that occurred here with the client ID. But for portal.azure.com, you're actually going to want to be able to specifically grab this C44 client ID. And I know this because I did a lot of testing, and this pertains to portal.azure.com. There is a web page that I reference in my blog posts where you can look up common Microsoft client IDs. But if you ever find yourself in a position where you get a response like client, your tokens are unauthorized, make sure you just do a double check and look at the client ID you are supplying whenever you're trying to obtain access tokens with road tools. So for this case, we now have our client ID, we have the origin, and we have our refresh token that we are going to be using to obtain new access tokens and hopefully complete our Road Recon collection. So we'll come back over to the terminal and we'll start with Road Recon off. We're going to set the client ID. We'll include the origin, and that's going to be our portal.azure.com right here. And then the last piece we're going to need is the refresh token, which we'll just grab this and copy and paste. And with that, we'll go ahead and request our tokens. Tokens were written to .roadtools.auth. So that is exactly what we're looking for whenever we're trying to use this new method of obtaining tokens. And with that, we should be able to just initiate our Road Recon gather, knowing that our tokens were written out. We can see here there's a couple errors coming through for 403s. And this is part of that piece that I mentioned previously, where not every token is created equally. So you may run into cases where certain APIs or requests aren't permitted for the specific token you're using. It's not the end of the world because we'll still get a partial collection out of this, but I have found I tend to get a lot better results when using things like SharePoint tokens or graph.com tokens have worked a bit better as well. This Windows graph.net token with the restricted user impersonation could be limited in part, and part of the reason that we're getting some of the results here. So while that's running, I'll go ahead and pop over here and we'll go to Office 365. And we just want the regular OA portal. And we'll inspect. So make sure we're checking the network, trying to look for tokens, and then we'll sign in. And now we're getting a lot of tokens here. Token client request ID right here. We got office.com, substrateoffice.com, graph.microsoft.com. So that's definitely one of the better ones. And same thing as when we're looking at the portal, this is just a single page application. It's doing token requests. We can see a client ID that's being associated with each of these requests. And this is scoping different tokens for some of the backend resources it's trying to obtain. And we'll grab a refresh token right here. Looks like Road Recon's almost complete. But here we go. Grab that out. And then we'll grab the client ID, which again, for this piece, it would be good to double check, but I'm confident, having done this multiple times previously during testing, that this is going to be the correct client ID associated with it. And now we're going to go ahead and grab www.office.com. Now we can see that our previous gather has concluded. We do see that there's some groups that could not be enumerated, but if we start Road Recon and GUI, and we'll go ahead and navigate to the localhost web server, port 5000. We do see we have our partial collection completed. We were able to enumerate information about users, groups, identify applications and principals, but we see these zeros for devices and administrative units, and that's some of those restrictions on what we would be able to access with the tokens or not. We can see tenant domains and come over here, enumerate some of the information. Now, if we try to hit any of those devices, we don't have that data yet. So again, grabbing the SharePoint token here, client ID, we're going to go ahead and Control C this, and we're going to do our auth again, this time with our new client ID. And we're going to set the origin to office.com. And finally, the refresh token for that SharePoint token that I know tends to work a bit better. And with that, our tokens were written out, and we'll go ahead and hit our Road Recon gather again. And this time you'll see that we don't have those immediate 403 errors as it's starting to iterate through things. If we do hit an error, that's going to be slightly uncommon for what I'm expecting here. Again, SharePoint tokens, graph.com tokens tend to be a bit better in many of our tests that I've done up to this point. We can see same amount of groups because we're still hitting the same tenant and targeting the same information here. Just let it go ahead and run through. Some offset considerations for anyone that's using this for red teaming and doing some covert testing. You want to make sure that if you are doing your collection, try and proxy back through the system where you obtain these tokens from. Some organizations, again, particularly the well-hardened client we had, has Microsoft's advanced monitoring enabled to be able to identify when access tokens and refresh tokens originate from other IP spaces than where they were originally requested from. We tend to follow the principle that if you obtain it on that system, use it from that system within our team. And with that, all of our groups are collected and processing has been completed. We can start up our GUI again. And if we navigate back to our local host, this time we'll see we have the administrative unit and device information as well.